It is day 15. We are once again back with our encode program, and I was reading through the problem today, and I'm pretty sure this is a reference to the Apollo 13 movie, or actually, sorry, the Apollo 13 movie and real life space exploration mission. But basically, we are given a remote control droid that we need to find the damaged oxygen system with. We can provide it inputs to move north, south, east, and west, and every time it moves, it will return whether or not it's hit a wall, didn't move, whether or not it actually moved in that direction, or if it moved in that direction and is now at the location of the oxygen system. We don't know where the oxygen system is, so we're going to have to kind of randomly control the drone or the droid and kind of hope to hit it. So I have all the code set up for our encode program, providing inputs and simply outputting what it sees. So to start off, I think the best way to go about it is to find some sort of search algorithm. So I think the easiest search algorithm is to be kind of just moving randomly, but a little less randomly. I'm actually going to grab my vector stuff from past days, if I can remember where vector is. Which day was vector? Here's vector. Oh, it's vector 3i. There we go. Here's vector 2i. So I'm actually going to grab this and use it in day 15 again, because we'll be dealing with positions, and positions will be vectors. So let me grab this, and I'm actually going to change this hash code to be return this dot. Whoops. If I don't mess it up, return this dot toString dot hash code. That should be a little bit of a better hash code. Okay, and then we're going to need a map of vector 2i and an integer to represent what is at that location. If I can spell vector 2i right. Okay. So there is our locations, and I'm actually going, okay. So we're going to assume this all works for now, and what we're going to do is output to console again. So I'm actually going to do a list of vector 2i. This is going to be keys equal to locations dot key set. I need to import that, and we're going to do it this way. New array list, put locations in there. And then we're going to then sort the keys, and it's going to be comparator AB, and we're going to return A dot if A dot Y does not equal B dot Y, we are going to return integer dot compare A dot Y and B dot Y. Caps lock got stuck on. Okay. Otherwise, just compare the x's. There we go. So that will then sort these vectors, and I'm going to have to go through, find the lowest x. That way we can actually print into console for vec in keys if vec.x is less than lowest x. There we go. So now we should have the lowest x integer.max value. And what we should be able to do now is just go through all of the keys, keep track of our current y. To integer dot maxint. Keep track of our current y, and then basically check if the vector dot y does not equal current y. We will have to set current y to the current vector y and then jump to a new line. This is how we will be able to show in console what we've seen while also doing read lines. So this is a little bit easier than just setting up a JPanel in Canvas. I found this to be much more helpful. But then just do system out print line blank, and then go ahead and just do system out dot print of the scanner. Oh, I need one thing real quick, but not scanner, sorry, locations dot get, or locations dot get, and this is me back. And what we currently need to do is also, when we switch to a new line, gotta do while int x equals vec dot x, while x is greater than lowest x, system out dot print, and this will be a wall. I'm going to use what they show for their examples. And then x minus minus. So we're going to output a bunch of walls until we hit to where the lowest x is, and then we'll print like normal. So let's do an if int tile ID. I should call it tile ID, sure. If tile ID equals 0, we are going to output a wall. Otherwise, output 1, there'll be a space. Otherwise, if it's 2, we want to output an X, as in we found it. Okay, so there is the output done. Now we just need to deal with the input. So I'm gonna guess the drone or the droid's gonna start at 0, 0. Yeah, we can choose it to start at 0, 0. So we're going to construct a vector 2i. I'm using a lot of vector 2i's. I should just make them a class, but so vector 2i, and this will be current location of the drone, new vector 2i 0, 0. Okay. So now for the search algorithm. I'm trying to think what I haven't done really any search algorithms in my life. Let's do this. So input will not need a scanner. No scanner will be needed. And what we're going to do is also need this to be a lambda without. So it's going to move. It's going to send. Let's just have it send north for now. So 1. Set input as a 1. Execute, and we're going to need. When it outputs, sorry. When it outputs, it'll say if output equals 0, we have not moved. So current location has not moved, and we're going to need to have to store that. But for now, we know that locations put new vector 2i current location dot x current location dot y plus 1. I'm just for testing, I'm just gonna have this go as north as possible, and we're gonna put in a 0. Current location does not move, else if output is equal to 1, we are going to move the current location dot y plus plus, and then we're going to set that equal to a 1. And then lastly, if it is somehow a 2. We'll move there, but then set that to a 2. All right, so now if we run this, no scanner, right? Now if we run this, it should run until it hits a wall and then halt. And then we'll do current program. Can I halt the program? So I guess I need to add a method to halt it. Why not? Public void halt program this dot is halted equals true. So I'll go ahead and just halt the program just for testing purposes. Current program dot halt program. There we go. Give this a run, and we should see in our console a line just going straight up until we hit a wall. All right, so we also now need an integer array here to keep track of the last move. I have to do this because of the way this lambda works. We need to put it into here. So we will have the input just dumbly put it in. So we'll have the logic be down here. So we'll do just last move 0. So we'll have it move up first and go from there. Okay, so we gotta make this a little bit smarter then. Okay, so we hit a wall. What we're gonna do is, yes, increment this, but we're gonna then check if the direction it's gone has already been visited. So for I equals 4 or I equals 0. I think this will help us. So we wanted to pick a new direction. So when it hits a wall, we will first check each direction. So let's call this the look. The look location. I should add a method in here to take in a vector. Let's have it take in a vector. This will make things our lives a lot easier. When creating new vectors, whoops, there we go. Make our lives a whole lot easier. So now we can just do current location and current location. There we go. Make our lives easier. Okay, so now we have a local location. So what we're going to do is we're going to look in all 4 directions. Let's just have it preference going up. Let's just have it, yeah, preference going up. So what we're going to do is if locations dot contains key, if it does not contain the key of local location, let's just call this north. Current location dot x, current location dot y plus 1. So north, east, south, west. Actually, I'm gonna do north, south, south, west, east. Yeah, west, east, minus 1 and plus 1 down here. So if it does not contain north, we will set current direction equal to 1. There we go. Now it should explore. Like that-ish. Okay, it's exploring. But it's been unsuccessful in finding. Oh no. Okay, so I spent some time working on the recursion here a bit. What I ended up doing, I ended up redoing it and made it a lot cleaner. So basically what it does is right when you call the find visited, it adds the location that you're looking around to the path. It then checks for unfound locations. And then if it can't find any unfound locations adjacent to where you currently are, it will then recursively call, but it'll only recursively call if the place you're going to has not already been included in the path. And then from there, it doesn't care about the shortest path, it just finds a path. So it starts by going north first, and then south, east, west. So it just tries to find a path. Basically a good example is it just like snakes out, and it prefers to go north, and it goes all the way north as far as it can, and then it slowly kind of scans out that way. Yeah, so it does work. Ends up it creates the whole map, and it does find the X here. So I could do. So now that we have this map, I could calculate it manually, but I'm sure it would take quite some time to do so. Yeah, as you can see, obviously calculating manually is not the right solution. So I need to do a path find from there to X. Yeah. So it wasn't really necessary to figure out the entire structure of it. I could have stopped this early, but it didn't take too long. So, yeah, so we'll have it run. And then once it halts, go ahead and do an out. And then now we need to find, instead of find not visited, find the end point. So we have directions.size. So we go until the find not visited returns a list of 0. Because once it does, it means there is no more not visited points. And there we go. So now we have an entire filled out map. Okay, so now we need to do a search algorithm to get from here to the X in the least amount of steps. So I'm going to do get to, or go to point. I'll give it the path, and I'll give it the location where we want to go to. So this gets removed. So we don't care about that. We care about this. So this is, instead of find not visit, this is go to point. Need to do path dot remove path dot size -1. That does need to happen. This should give me 210. No, it does give me 210. Okay, I was right then. Never mind. So there we go. So there's our map, or there's our like maze map. It's actually a maze, I guess. Our maze, length of 210. Cool. So let's go to part 2. Let me read part 2, and I'll get back to you guys. Okay, so part 2 asks how long it will take for the entire map slash maze to be full with oxygen. If oxygen expands every 1 minute to all adjacent tiles that it is currently in. What we will do is actually, it's not too bad to do. We can go through part 1 and then we can do a for loop on the key set. This is going to be a vector 2i key, and it's going to be in locations.keyset. So we actually go through our keys, set this to be 0, meaning that there is no key locations dot put key, and just set to 0, meaning that there is no oxygen there. And what we can do is we can do vector 2i. This is the oxygen origin. Check here if before we set it, we do a check for if locations dot get key. There we go. So this will give us the oxygen origin. So what we can do now is go through. We can do a while loop. So while not full. So int I equals 0, boolean not full equals true. So while it's not full, we will go through. We will have to then expand the oxygen. Okay, so while it is not full, what we'll do is we'll have to go through. So we're actually gonna have to do then, before we do this, locations dot put oxygen origin to a 1. Set it equal to null by default, and no gets set. So we increment I every time. Actually, we do while not full. Oops, sorry. While not full. So we're gonna change it to while not full. We're gonna go through each location and we're gonna do a check. If it equals a 1, we need to go and set all of the adjacent ones equal to 1. And that means full equals false. But we will set full equal to true every loop, and hopefully it'll get set back to false. And then do a check here of if no, I++ there. Increment I, and then what we can do is at the very end do part 2, and we just give it I. And the only thing left to do now is here. So when we get a key, if it equals 1, we want to get all 4 directions. Instead, this is going to be key instead of lock. Get all 4 directions and do a check if locations.contained key north locations.put. Let me hold the set. So set. Or we do a list keys. This way it doesn't update. I don't know if this will update as we set stuff. I don't think so. But we'll do keys equals new. But just to avoid this like spreading doubly in one occurrence, because I'll do it like this. So locations then put north and a 1. And do this check for each one of them. South, west, east. Give this a run. Give me an answer. Oh, sorry, this goes in an else. If there's one with 0, then it's not full. My bad. Takes 20? No way. Oh, hold on. That's right, but it ignores walls. It ignores walls, right. So we do need to set, because they're all 0 or 1. So we do actually need to do this to set that, and then locations dot put, and we put key, and it's going to become a non-wall, or non-wall, which is a 1. Okay, else if locations equals 0, it's not full, and then we set all of these to be 3, just because. So if it equals a 1, so if it equals a 3, if we do that, there we still have walls now. It contains key and locations dot get north does not equal 0. There we go. That way we aren't going through walls and ignoring it that way. This should be what we need. What we can do is we can do a draw again. I can reuse the outmap bit. Can reuse outmap after every iteration to draw the outmap, but provide it an empty array list. Provide it a new or empty array list, and then in here just add support for 3. And 3 can be a dot to represent air or oxygen's being there. Well, there's the issue. There's nothing. Oh, we didn't start. Hold on. I forgot to start where the oxygen goes. Sorry, instead of setting this to 1, put it to a 3. That way it starts it. We actually don't need that. Just wherever the ending bit is, set it to 3. That way the oxygen starts. There we go. 144. Let me remove that bit. Put in 144 as our answer. And it's too low? Oh, it's going too fast. Because it was here, so it was below the S there. Now it's above the S. Okay, so it's just going too fast somehow. That's what I thought this would fix. But I guess not. Oh, it doesn't actually change. Doing this didn't actually do anything. Okay, so we're gonna use a 4 then. So we're gonna set everything to a 4. And then what we'll do is we'll go through this again. After we do it, we'll go through it again and do a check on the location. If the location get key is a 4, we then set it to a 3. That way we can no longer double set them. So it'll set them to 4 until they've all been gone through, and then I'll set it to a 3, so that way it can then be expanded upon. I need to do does not equal 0 and then does not equal 3. That way it doesn't replace a 3 with a 4 and prevent expansion like it's currently doing. Oh wait, because they're all north. That's my issue. Whoops. My issue is I set them all to north. So, but I believe it's just now -1. So I believe it is just 290 instead of 291. Yeah, it was 290. Okay. There we go. We finished it. We finally did it. We finally got it. Took a good amount of time. But I get the off by 1 stuff is always fun to deal with. This is probably the longest code I've had to write for these days, but there's just kind of a lot of duplicate with directions and stuff. Either way, so we first load up our encode program just like always, and we create a map of locations. The location stores the actual location in the map as well as what is at that tile. What we do is we go through while the program is not halted, we give it some sort of input. We start the input at what, 0? I think, or 4. We started at 4, so that it technically moves east or west, but either way, so it starts moving at a direction. It'll keep moving that direction until it hits a wall, or actually, no, it won't, but it'll start at a direction, it'll move in that direction, and then what it'll do is it will seek out the nearest unmapped area in the map using our little method find not visited down here. So it'll try and seek out the tile locations it has not yet visited, and it will actively try and move towards them. And then that is part 1. So it'll map out the entire grid in part 1. So that's also used for part 2. But it'll map out the entire grid. And what it'll do from there is it will then do a path find from the start to the end to find the shortest path. That completes part 1. So then for part 2, we now know where the end is. We then reuse our tile map to do new tile IDs, to where we fill the ending location with an air tile ID, and then every loop we update those tile IDs to then expand by 1, and they keep expanding until the entire map has been filled with air or walls, and then we return how many steps that took. Not bad. What I'm probably going to do is right after I finish recording is move this vector2i stuff to its own class, as well as 3i, just to make it more uniform between the days. But anyways, that will complete today's day 15. It was not too bad. It was just a little more of the only hard bit was the pathfinding. I have not really done any pathfinding, so this was new to me. But otherwise, it wasn't too bad. If you know pathfinding, you're pretty good. But anyways, that's day 15. I will see you guys all tomorrow. Peace out.